The hottest day of the year in Santiago, Chile, on average, is January 7th, when the average high temperature is 29 degrees Celsius. The coolest day of the year has an average high temperature of 14 degrees Celsius. Use a trigonometric function to model the temperature in Santiago, Chile, using 365 days as the length of a year. Remember that January 7th is the summer in Santiago. How many days after January 7th is the first spring day when the temperature reaches 20 degrees Celsius? So let's do this in two parts. So first, let's use a trigonometric. Let's try to figure out a trigonometric function that models the temperature in Santiago, Chile. So we'll have temperature as a function of days, where days are the number of days after January 7th. And once we have that trigonometric function to model that, then we can answer the second part, I guess the essential question, which is how many days after January 7th is the first spring day when the temperature reaches 20 degrees Celsius. So to think about this, let's graph it. And it should become pretty apparent why they are suggesting that we use a trigonometric function to model this, because our seasonal variations, they're cyclical. They go up and down. And actually, if you look at the average temperature for any city over the course of the year, it really does look like a trigonometric function. So let's this axis right over here. This is the passage of the days. Let's do D for days, and that's going to be in days after January 7th. So this right over here would be January 7th. And the vertical axis, this is the horizontal axis, the vertical axis is going to be in terms of Celsius degrees. So this, let's see, the high is 29, and I could write 29 degrees Celsius, and then, or the highest average day. And then if this is 0, then 14, which is the lowest average day, 14 degrees Celsius. And so our temperature will vary between these two extremes. Our temperature is going to vary. The highest average day, which they already told us is January 7th, we get to 29 degrees Celsius. And then the coldest day of the year, on average, you get to an average high of 14 degrees Celsius. So it looks like this. We're talking about average highs on a given day. And the reason why a trigonometric function is a good idea is because it's cyclical. So if this is January 7th, if you go 365 days in the future, you're back at January 7th. So if the average high temperature is 29 degrees Celsius on that day, the average high temperature is going to be 29 degrees Celsius on that day. Now, we're using a trigonometric function, so we're going to hit our low point exactly halfway in between. So we're going to hit our low point exactly halfway in between, something right like that. And so our function is going to look like this. Our function, so let me just draw the low point right over there. And then this is a high point. It's a high point right over there. That looks pretty good. And then I have the high point right over here, and then I just need to connect them, and there you go. I've drawn one period of our trigonometric function, and our period is 365 days. If we go 365 days later, we're at the same point in the cycle. We are at the same point in the year. We're at the same point in the year. So what I want you to do right now is, given what I've just drawn, try to model this right. So this right over here is, let's write this. This is capital T as a function of D. Try to figure out an expression for capital T as a function of D. And remember, it's going to be some trigonometric function. So I'm assuming you've given a go at it. And you might say, well, this looks like a cosine curve. Maybe it could be a sine curve. Which one should I use? And you could actually use either one, but I always like to go with the simpler one. You just think about, well, if these were angles, either actually degrees or radians, which trigonometric function starts at your maximum point? Well, cosine of 0 is 1. The cosine starts at your maximum point. Sine of 0 is 0. So I'm going to use cosine here. I'm going to use a cosine function. So temperature as a function of days is going to be some amplitude times our cosine function. And we're going to have some argument to our cosine function. And then I'm probably going to have to shift it. So let's think about how we would do that. Well, what's the midline here? Well, the midline is the halfway point between our high and our low. So our midpoint, if we were to visualize it, looks just like, so that is our midline right over there. And what value is this? Well, what's the average of 29 and 14? 29 plus 14 is 43 divided by 2 is 21.5 degrees Celsius. So that's our midline. So essentially, we've shifted up our function by that amount. If we just had a regular cosine function, our midline would be at 0. But now we're at 21.5 degrees Celsius. So I'll just write plus 21.5. That's how much we've shifted it up. Now, what's the amplitude? Well, our amplitude is how much we diverge from the midline. So over here, we're 7.5 above the midline. So that's plus 7.5. Here, we're 7.5 below the midline. So minus 7.5. So our amplitude is 7.5. The maximum amount we go away from the midline is 7.5. So that's our amplitude. And now let's think about our argument to the cosine function right over here. So we're going to have it's going to be a function of the days. And what do we want? When 365 days have gone by, we want our cosine, we want this entire argument to be 2 pi. So when d is 365, we want this whole thing to evaluate to 2 pi. So we could put 2 pi over 365 in here. And you might remember your formulas. I always forget them. That's why I always try to reason through them again. The formula is, you want 2 pi divided by your period and all the rest. But I just like to think, okay, look, after one period, which is 365 days, I want the whole argument over here to be 2 pi. I want to go around the unit circle once. And so if this is 365, if this is 2 pi over 365, when you multiply by 365, your argument here is going to be 2 pi. So just like that, we've done the first part of this question. We have modeled the temperature in Santiago, the average high temperature in Santiago as a function of days after January 7th. In the next video, we'll answer this second question. I encourage you to do it ahead of time before watching that next video. And I'll give you one clue. Make sure you pay attention to the fact that they're saying the first spring day.